Okay, so here's just examples. We're going to go ahead and graph this. I know before we put the key points on the board and we kind of had this table. It's kind of the thought process, but I'm going to go through how really you should start thinking about how to graph these. We're going to graph and identify the transformation. So graphing it, let's identify the transformation first, because sometimes that's helpful to know where the picture moves to. This is the only thing that's different. Vertical shrink by 1/2. So I know it's going to squeeze together, okay? So if you would like to pinch something close together. So what I do sometimes is in black, I'm going to graph sine. In red, I'm going to graph 1/2 sine. So I'm going to call this 1 and that -1. And one of the things that's helpful is I plot my 0, 90, 180, 270 little, coordinate thing here. And I know my points are 1, 0, 0, 1, -1, 0, and 0, -1. And because it's sine, I only look at my y values. And I go around the circle and I look at my y values, and I'm going to hit 360 twice. So okay, so I'm going to plot these values. So in black we have our traditional values. So we're at 0, 90, 180, 270, and 360. And we have this beautiful graph here. Hopefully Blake thinks that this is a nice enough picture for him. Fantastic job, right, Mr. Thornley? Thanks, Blake. I appreciate it. All right, so now here's what I'm going to do next. I'm not going to draw a table. I'm going to say, okay, it's going to be half the size, and it's going to shrink. This guy's going to come down, this guy's going to come up, and what we discovered was these guys that are zeros aren't going to change because we're multiplying by 1/2, and 0 times 1/2 is still 0. So hey, I'm 4 units from the origin, so now half of that would be 2 units, still 0. And now I have plotted a vertical shrink. So this guy right here in red is y is equal to 1/2 sine x. So I use the idea of what happens in the transformation of graph. I do not draw a table. You could do that if you want to, but when you got a test, you got to take a few questions. You don't want to be wasting your time with it. You got to be able to do it like this. So we're going to do another example here. We're going to identify the transformation. Okay, so we got an amplitude of 2 here. We got that negative in front. So it's going to be so A is equal, well, technically A is equal to -2, but the amplitude is always positive. So amplitude would be 2. So I know there's going to be a vertical stretch by 2. And I know that it's going to reflect over the x-axis. Okay, so here's what I do. I'm going to draw cosine. We'll call this guy 1. And we'll call this guy up here 2. So this is -1, and this is -2. This cosine we'll do in red. This cosine we'll do in blue. And I'll talk about what I do. First thing, I'm going to plot cosine. And we only need to plot the 360. And once again, and I know to put it in 2 increments because I know that vertical stretch at 2 is going to happen. And all I'm doing to get these values is I'm looking at these 4 points and I'm looking at all the x values around this guy. Okay, so I'm looking at this guy right here. So now I'm going to graph this guy. And I'm going to do it in blue, and I know it's going to be a vertical stretch of 2. So technically, I'm going to put green dots without the reflection. So without the reflection, there's going to be a green dot here, right? A green dot here, a green dot here, a green dot here, and a green dot here. But because of this negative value, what happens to these guys? They are going to reflect to the opposite side. So this guy is actually going to flip down to right here. So I think about the stretch and then I flip it, and I do that mentally. I That's how I think about it, and that's where you need to be to think about it. So that's going to be that guy. This guy, the mirror technically would be on the x-axis, so this would just reflect on itself. This guy would reflect up to here. That guy would stay the same, and then this guy would reflect down, and I have my graph. I'm going to go ahead and come back and erase these guys because that cleans it up a little bit. So I got a bunch of different colors here. Notice I'm not hitting the whole point. My graph is not perfect, but that point is there, so I see the majority of what you're doing, and that's perfect. So notice how the high points and the low points switched, and we also stretched by 2. So those are the processes that we go through to graph these types of functions.